Hello and welcome to everyone. Today we are going to discuss a topic which is known as traversing. Now under this topic we will try to focus on some of the points which is mentioned here. That is, methods of traversing we will try to know. Then checks in closed traverse. What are the various checks that we need to do in a closed traverse? Then we will see about traverse computations. Then we will see what is closing error. Now let us see in traversing what are the various methods, or before going to the methods, let us see what is traversing. By definition, what does it means is, it is a type of survey in which a number of survey lines from the framework form the framework, and the directions and the length of the survey lines are measured with the help of an angle measuring instrument and a tape or chain respectively. In traversing, what we will do is we will try to form a framework, and we will try to locate, or we will try to find out the directions or the angles and the lengths of the various survey lines which is going to form the framework using an angle measuring instrument, which may be a compass or any other means, and a tape for measuring the distance of the lines, or chain is also used. Now what do you mean by closed traverse? Now when we start plotting a traverse, we are forming a framework. If we start from a point and if we go around, and if the end point is meeting same at the starting point, then we will term that particular traverse as a closed traverse. When the lines form a circuit which ends at the starting point, it is known as closed traverse. Now it is suitable for locating boundaries of the lakes, woods, etc., and it is used for large area, surveying large area. Now what do we mean by open traverse? In open traverse, if the circuit which is forming the framework of the survey lines, it does not meet at the starting point, the end point doesn't meet at the starting point, then it is termed as open traverse. If the circuit of the lines ends elsewhere rather than at the starting point, it is termed as open traverse. Now it is suitable for surveying a long narrow strip of land which is required for road or canal or coastline. Particularly it is used for surveying of the roads, canals or coastline. Now let us see what are the methods of traversing. Traversing can be done using different methods. Now some of the principal methods are mentioned here as follows. The first one is chain traversing. The second one is chain and compass traverse, which is also known as loose needle method. Then the next one is transit tape method. Under transit tape traversing, we have first one as fast needle method, and another one is by measurement of angles between the lines. Then the next one is plane table traversing. Now let's try to make it more clear. What is chain traversing? What are chain and compass traverse, transit method, and plane table traversing? Now for methods of traversing, the first one is chain traversing. What is chain traversing? In chain traversing method, the whole work of the traversing is done with the help of chain and a tape. Now in chain traversing, we will use the help of chain or tape to do the traversing and to form the framework or the circuit of the particular survey lines. No angle measuring instrument is used, and the direction of the lines are fixed entirely by linear measurement. Here the directions is not directly measured, it is fixed by the lines entirely by the linear measurement. Chain and compass traversing. Now what is different? What is the next method, that is chain and compass traverse is? In this method, the magnetic bearing of the traverse lines are measured by a theodolite fitted with a compass. Now in chain and compass traversing, the magnetic bearings of the traverse lines are measured by the help of a theodolite which is fitted with a compass. The direction of the magnetic meridian is established at each traverse station independently. Here in chain and compass traverse, the direction of the magnetic meridian, which we are going to use for measuring the direction or the angle, is established at each traverse station independently. Now for each traverse station, the direction of the magnetic meridian should be established independently. The method is also known as free or loose needle method. Now this method is not so accurate. Now let's see the next. That is our fast needle method. In this method, the magnetic bearings of the traverse lines are measured by theodolite fitted with a compass, same as we have used in the our loose needle method. However, the direction of the magnetic meridian is not established at its station. Now here, the difference is that the direction of the magnetic meridian is not established independently for each station. The method is more accurate than the loose needle method. This is the another type of one of the method for transit tape traversing. Now let us see what is the other type of transit tape traversing. Or before that, let's see what are the lengths of the lines of the traverse are measured using a 20 meter and 30 meter steel tape. Three methods of observing the bearing of the line in fast needle method are. Now for measuring the bearing of the line, it's again classified into three methods. It can be measured using direct method with transiting, or direct method without transiting, then back bearing method. Now another type of the transit tape traversing is by measurement of angle between the lines. So we have to measure the angles in between all the lines. So in this method, the angles between the lines are directly measured by a theodolite. We use a theodolite and we will measure the angles in between each lines directly by using a theodolite. This is one of the most accurate in comparison with the previous three methods that we have just discussed. Then the magnetic bearing of any one line can also be measured, and the magnetic bearing of other lines can be calculated. Now here, for each line the magnetic bearing can also be measured, and the magnetic bearings of the other lines can also be calculated using the magnetic bearings of one line. Now here, how do we calculate? The angle measured at different stations may be either included angle, or it may be deflection angles. Now here we use this included angle and deflection angles, and we use some property of compass surveying, and we will try to find out. We can also find out the bearing of the other lines with the help of included angles or deflection angles and bearing of one line particularly. Now the other type of method for traversing is plane table traversing. Now plane table traversing involves the same principle as that in transit traverse. In this method, at each station the table is set, a foresight is taken to the following station, and its location is plotted by measuring the distance between the two stations. Now here, a station at each station the plane table is set up, and a foresight is taken to the following station, and its location is again plotted by measuring the distance between the two stations. The method is used to lay down survey lines between the instrument stations of a closed traverse or unclosed or open traverse. This method is used to lay down the survey lines between the instrument stations for a closed traverse or unclosed traverse. Now let us see what are the various checks that we need to perform in a closed traverse in order to check whether the traverse is it is satisfying all the properties of the traverse or not. The first one, there are two types of errors involved in traversing. It may be linear or angular, the type of the error. First one is linear and the other one is angular. For checking the linear measurement, chaining each station line survey line in a second time, preferably in reverse direction on different dates and by different people, is preferred. Now for checking particularly for linear error, what we will do is we will try to do the survey again in the reverse direction on different dates, not on the same day. We will try to do it in the next on different dates and by the help of different people. So in order to, this is done in order to minimize or in order to nullify the error that we will find out in linear measurement. The angular measurement, however, checks can be done for angular measurement is as follows. Traverse by included angles. Now this is one of the check in which we will try to find out the error in angular measurement. Traverse by included angles. The property here is the sum of the interior angles should be equal to twice n minus 4 times of right angles, where n is the number of sides of the traverse. So what we will do is we will try to satisfy this equation, that is twice n minus 4 times the right angle, that is 90 degree. So the sum of all the interior angles should be equal to this equation, that is twice n minus 4 into 90, where the value of n is the number of sides of the traverse. Then if the exterior angles were measured, now first what we have done is we have measured the included angles. However, if we have measured the exterior angles, then their sum should be equal to twice n plus 4 times of the right angles, that is twice n plus 4 into 90. The sum of the interior angles should be equal to twice n plus 4 into 90. In the next check, there is traverse by deflection angles. Now we will use deflection angles to check. The sum of the deflection angles should be equal to 360 degrees, taking the right hand deflection angles as positive and left hand angles as negative. Now the sum of the deflection angles should be equal to 360. So all the deflection angles that we have measured should be equals to 360 degree. The sum of that should be equals to 360 degree. Now how we are going to take it? If we are taking the right hand deflection angles, then it is taken as positive, and if we are taking the left hand angles, and it should be taken as negative. Now traverse by direct observation of the bearing. How it is done? Let us see. The forebearing of the last line should be equal to its back bearing plus or minus 180 degrees measured at the initial station. Now this is the relation that we should follow. We should check whether the forebearing of the last line is either equal to back bearing plus minus 180 degrees. That we have to check at the initial station. Now for open traverse, there is no direct check of angular measurement is available. However, we can use it several trial methods or several other types of methods that we can check it in an indirect way. Now let us see plotting a traverse survey, how we should plot a traverse survey, what is the process or what are the types. Now the two principal methods of plotting a traverse survey are angle and distance method and coordinate method. Either we are going to use the angle and the distance method, or we can use the coordinate of a particular line, and we will find out the coordinate of the particular line, that is your latitudes and the departures, and we will plot the traverse survey. We can do the traverse survey in this way. The angle and distance method. The distance between stations are laid off to a scale, and angles are plotted by using the methods such as protector method, tangent of the angle method, or the chord of the angle method. Now using the distance or between the stations are let off using a scale, or the angles can be let off or plotted by using these methods such as protractor method, tangent of the angle method, or the chord of the angle method. Now this is suitable for small surveys and is much inferior to the coordinate method of plotting an angle. Now this particular angle and distance method is suitable only for small, relatively smaller surveys. However, for large area of survey, coordinate method is more preferable. Now what is coordinate method? Survey stations are plotted by calculating their coordinates. Now in here, the distance in between the survey stations are plotted using coordinates, which we have to calculate by ourselves. Then we will try to put it in the plotting of the survey. More practical and accurate one for plotting traverse or any other extensive system of horizontal control. Now here this coordinate method is more practical and it is more accurate for plotting traverse. Biggest advantage is that the closing error can be eliminated by balancing prior to the plotting. Now here the error can be eliminated by balancing the traverse before plotting it actually. Now let us see what are the traverse computations. Here we have to find out the latitude and the departure. Now let us understand what is a latitude and departure of a particular line or a particular distance between, which will form a distance between two stations. What is latitude or latitudes of a line? The latitude of a line is the coordinate length of the line parallel to the meridian. Now here we have a line. Now the line will be having a coordinate which is parallel to the meridian. So that particular line or that particular coordinate of the line is termed as latitude of the line. If the latitude is towards the north, it is termed as northing and it is taken as positive. Now the coordinate or the latitude of the line, if it is towards the north side, then it is termed as northing and it can be taken as positive. If the latitude is towards south, it is called as southing and taken as negative. Now if the latitude is towards the south side, it is termed as southing and it is taken as negative. Now let us try to understand what is latitude in a pictorial representation, or let's complete what is departure and we'll see later in a pictorial representation. Now departure of a line is the coordinate length of the line perpendicular to the meridian. Now here we have a line which will have a departure value. Now what is that departure value? It is the coordinate length of the line, of that particular line, which is measured in a perpendicular to the meridian. Now here we have the meridian, north-south meridian. If we are measuring it in the east or the west direction, then that particular coordinate of the line will be our departure. Now if it is measured in the east direction, it is termed as easting and it is taken as positive, and if the departure is towards west, it is termed as westing and negative. Now let us try to understand what is latitude and departure actually means. Now let us say this is our coordinate system in which north and south meridian is here, then east and west is here. We have, this is the first quadrant, this is our second quadrant, this is our third quadrant, and this is our fourth quadrant. Now we have a line AB which is in the east-west, northeast direction or the first quadrant, which is making an angle theta with the meridian. Now what is our latitude? Latitude is the line which is measured parallel to the meridian, or let us say the length of the line is L. Now what should be our latitude? Latitude will be given by, it is the distance of the line which is measured parallel to the meridian, that is north south direction. Now this will be our latitude value. Now with the property of the triangle we can find out L is equals to, capital L is equals to, capital L denotes our latitude value, which is given by small l cos theta. Now what is departure? Departure is the coordinate length of the line which is measured perpendicular to the meridian, that is north south direction. We have to measure it in the perpendicular direction. Now here is our departure, which is represented by capital D, and it is equals to L sine theta. Now let us see the values for which in first quadrant, second quadrant, third quadrant and fourth quadrant, what will be the values of what sign it will carry. The latitude or departure will be positive or negative. Let us see. Now here the line is in the north direction, so the latitude will be positive, and also the departure is measured in the east direction, so it should be positive in the first quadrant. So both the departure and the latitude values will be positive here in the first quadrant. However, if we move on to the second quadrant, the latitude is measuring in the south direction or southing, so the value of the latitude will be negative, and the departure is still in the east direction, so it should be positive. So the value of the latitude will be negative and the value of the departure will be positive. Now let us see in the third quadrant. In third quadrant, both the latitude and the departure will be negative. Why? Because latitude is measured in the south. Now here in the third quadrant, latitude will be in south and the departure will be also in the west direction, so it should be in negative in both the conditions, that is latitude and departure. Now in the fourth quadrant, the latitude is again, it is coming to the north direction, so it will be positive, and departure is in the west direction, so it will be negative. So it overall, if we see the values or the signs of the latitude and departure, so it is shown here in the different quadrants. If the line AB is in the first quadrant, what should be the value of the latitude and departure? Second quadrant, third quadrant, fourth quadrant, it is clearly shown in this particular figure. Now let's move on. Now in order to determine the sign of the latitude and departure, the bearing is to be converted to quadrantal bearing. Now if we have been given with whole circle bearing system, then we have to convert that particular bearing into quadrantal bearing in order to determine the sign of the latitude and the departure, which we have already discussed here. Now let us see some of the properties of a closed traverse. Now this we will use in later on for checking the closing error or the omitted measurements. For any closed traverse, sum of the latitudes of all the sides is 0. Now if we take a closed traverse, now the sum of the latitudes of all the sides should be equal to 0. That is, summation of L, that is sum of the latitude, is equals to L1 cos theta 1 plus L2 cos theta 1, and so on, and the number of latitudes we have to add up, everything should be equal to 0. Then another property is, for any closed traverse, sum of the departures of all the sides is 0, and again the departures sum should be 0, which is given by summation D or departure is equals to L1 sin theta 1 plus L2 sin theta 2, and so on, and it should be equal to 0. This should be kept in mind. Now next we will try to see about closing error. What does closing error means? Now whenever we are doing a survey or traversing on the field, and we are measuring all the distance and the bearings of the lines, and we are trying to plot it in a survey, we are trying to plot it in a sheet, then sometimes it happens that the traverse is not closing, or the starting point of the traverse and the end point is not meeting at the same point. So this type of error is called closing error. When a traverse survey performed in the field is plotted, the traverse does not close most of the time. This is due to the errors during measurement in the field. We are making some errors during measurement in the field. So due to these errors, this traverse is not closing. Such kind of error is known as closing error. Now let us see a traverse survey in which this is a line AB, then another line that is BC, then CD, DE. In order to have a correct traverse, the line EA should be closing. However, it is not meeting at A. It is ending at A dash. Now in this case, the traverse is not closing. A should be coinciding with A dash. So however, it is not occurring in this way. Now in this particular figure, the error amount is A dash. Now what is that is your A dash, which is represented by your dotted line, yellow line, A dash. Now in order to make this thing close, we need to know the departure and the latitude of this particular line A dash. Now the latitude of the line A dash is equals to summation L. That is our summation L is our sum of the latitudes of all the lines. This is our summation L. That is the latitude of the line AA. Now why it is the summation is, in order to have a value, the latitude should the latitude of line AA dash should be in such a way that it should not it should be making a closer to the traverse. So what is the property of a closed traverse? The property of the closed traverse is such that summation of all the latitudes of the line should be equal to 0. So in order to make it 0, it is the latitude of the line AA dash is the summation of all the latitudes of the survey lines, where the summation L is equal to sum of the latitudes of all the lines of the traverse. Now what will be the value of AA dash, departure value of AA dash? The departure value of AA dash will be similarly equals to summation D. That is our here represented here by the yellow dotted line, summation D. Now what is summation D? It is the sum of the departures of all lines of the traverse. Now we will find out the distance AA dash using the property of a triangle or right angle triangle. Now we have the perpendicular and the base values here represented by our summation L and summation D. Now let us see the picture again in a more magnified way, where we have a triangle, right angle triangle here, in which the perpendicular is D and the base is summation L. Now the length of the AA dash or the closing error is equals to root over, this is nothing but your Pythagoras theorem, root over summation L square plus summation D square. So we will find out the length of AA dash by using this particular formula. Then the direction of the closing error is given by, or the angle of the closing error is given by tan theta equals to summation D by summation L, where theta is equals to tan inverse of summation D by summation L. Now by using these two formulas, we will try to eradicate, or we will try to remove the error by finding out the distance of the error or the amount of error or the angular or the direction of the closing error. Now this comes to the end of today's lecture. Let us come up with some other topics related with traversing in the next video, and we will try to solve some problems related to this. Thank you everyone.